Over here I have just another simple movement, and you can see, if you take a look at this, you'll be able to see how these gears kind of work together. And I'll show it like so. And here I am just slowly moving it with my hand, and you can see the gears turning on the inside. Meanwhile, this center arbor here is the hour and minute hand, and you can see that moving at a much slower pace. So the reason for all of these gears is to take the power from this spring and to make it slower. So you have different ratios here and different size gears until you finally get to the top, where it's actually moving at a rate that can be regulated and is very close to, say, maybe 1 beat a second, or maybe a little less, depending on how you want to have these set up. In many cases, we have clocks that are adjusted and geared differently because of the case that they go into. For instance, a big grandfather clock like we see over here on the wall would probably be running slower. That's why the need for the big case, so the pendulum can move slower. A smaller clock, like some of these on the wall, tend to run faster, as you can see. This one's moving fairly quickly there. And that would need gearing that makes the drop much shorter, like this, as opposed to something that goes all the way down to the floor like a grandfather clock. So that's why you have different gear ratios, and it's primarily for the cases that the movements are put in.